Hello and welcome to Advanced Chemistry. I'm Dave Hicks. Today we're going to talk about intermolecular forces. So when we get done today, you should be able to describe intermolecular forces and be able to predict the changes in some of the properties affected by intermolecular forces. So what are intermolecular forces? Well, it's the force that holds one molecule to another molecule. It's caused by positive and negative attractions, with protons and electrons attracting each other, and it's governed by Coulomb's law. So the forces are not these forces here, that is between or inside of, these molecules. Those are covalent bonds, and they're much stronger than intermolecular forces. The intermolecular forces are the forces that are between the molecules. So here. It's the forces that hold together all of the molecules, but they don't hold together like covalent bonds, the chemical bonding of it. So here's some properties and some ways that intermolecular forces show themselves in the world around us. First of all, intermolecular forces are the things that hold molecules together. So we wouldn't have a liquid or a solid if it weren't for intermolecular forces. Everything would just be a gas and no molecule would ever stick to another molecule. And since they're responsible for holding molecules together, boiling points and melting points are affected by these intermolecular forces. Since boiling is separating molecules and melting is also separating molecules, the temperatures at which this happens are affected by the intermolecular forces. As the intermolecular forces increase for boiling points and melting points, you're also going to see an increase in those as well, because the intermolecular forces are going to be holding them together tighter, so it's going to take a lot more kinetic energy to separate them. Viscosity is another property that's affected by intermolecular forces. It's the resistance for something to flow. We usually think of it as in liquids like honey. Honey is very thick, very viscous, say has high viscosity, caused by all of the sugar that's inside of it. And so because, again, this is something where it's resisting the movement of the molecules, as the intermolecular forces increase, so does the resistance to the flow. Vapor pressure is a little bit different. Vapor pressure is for where molecules escape, and the more molecules that escape, then the higher the vapor pressure is going to be. You may see this with things like maybe gasoline. The gasoline can, maybe when you take the top off of it or off of the cap off of your automobile, you might hear a release of pressure, and that is the vapor pressure of the gasoline. So since it's about escaping molecules, and the more escaping molecules will increase the vapor pressure, so as the intermolecular forces increase, the vapor pressure is going to decrease. Yes, it's going to decrease, because if I'm holding them together stronger, there's going to be fewer of them escaping, right? So something like gasoline must have a low intermolecular forces, weak intermolecular forces, and that's why the vapor pressure is so high. The heat of vaporization or fusion, or the amount of energy that's needed to boil something or melt something, again, we're measuring how much energy do we need to boil or melt something. So as intermolecular forces increase, so will this. Now, solubility is also another property that is highly affected by intermolecular forces, but solubility is talking about two different things. It's talking about a solvent and a solute. And so I'm not necessarily going to be looking at whether the intermolecular forces of these increase, but I'm going to be looking at the idea of whether or not the intermolecular forces are similar. There's a rule, maybe you've had a science teacher teach this to you along the way, and it says like dissolves like. And what we mean by this as scientists is that things that have similar intermolecular forces will dissolve in each other. So, you maybe heard polar molecules will dissolve in polar molecules. Nonpolar molecules will dissolve in nonpolar molecules. Well, that is part of its intermolecular forces is caused by whether it's a polar molecule or a nonpolar molecule. Okay, well, I hope you got a better feel for what intermolecular forces are and some of the properties that are affected by them. I also have some other videos that are along this here. One of my other ones is going to be on the types of intermolecular forces, and you may want to check that one out because that'll help you to identify intermolecular forces. Until then, I hope you have a good time with your chemistry.